Okay, so if you guys have not already, make sure that you stop this video and go ahead and do the warm-up before we get started, just to make sure that you're on track. Today we're going to look at solving inequalities by adding and subtracting. Okay, so let's look at this first warm-up problem. It says that the temperature must be at least -10 degrees Fahrenheit. Well, we need to decide if we're going to include -10 on our line, and it tells us it needs to be at least -10. So that means it can be -10. So we're going to draw a solid circle on the -10. And then if it's at least -10, that means it can be more than -10 as well. So we're going to color everything to the right. So all the values to the right of -10, also including -10. Then it says that the temperature must be no more than 90 degrees Fahrenheit. Okay, again, meaning no more than, that means we are including 90 degrees. So we're going to do a closed circle at 90 degrees. And it's telling us it's all the temperatures below 90 degrees because it can't be above it. It says no more than. So you should color your line this way. Okay? All right, for our equations, we're just going for x minus 4 equals 10. We're going to add 4 to each side, add 4 to each side of the equation, and then we're going to get x equals 14. That's what you should have gotten. Okay, for the next one, we're going to subtract 1.1 from each side. And if we subtract 1.1 from 15, we will get x equals 13.9. So if you don't understand that, make sure you ask. Okay, so today, like I said, we're going to look at solving inequalities by using addition and then solving them by using subtraction. Solving one-step inequalities is a lot like solving one-step equations. You basically do the same thing, you're just treating the inequality like an equation. To solve an inequality, we need to isolate, make sure you guys get that, you need to isolate the variable by using inverse operations. So just like we've been doing with regular equations, but now we're going to have an inequality sign instead. Okay, so for example, if I have the inequality 3 is less than 8, I can add a 2 to both sides and it will not change the inequality, okay? As long as I do something to both sides, I have not actually changed the inequality. Same thing with a subtraction. If I subtract something from both sides of the inequality, I haven't actually changed anything. I'm just moving things around. So we're going to use these properties when we go to solve our inequalities. Okay, just a helpful hint. Remember that we use inverse operations to undo an operation in an equation, and we're also going to do the same thing for inequalities. If the inequality contains addition, then you're going to use subtraction to undo it, and if it contains subtraction, then we're going to use addition to undo it. Okay, so here we go. We have the inequality x plus 12 is less than 20. Okay, I want you to pretend like this inequality sign is an equal sign. So we have two sides of it, and we want to isolate this x. So that means let's look at what's being done to the x. Well, we're adding 12. So in order to get rid of the 12, we need to use the inverse operation, which means we subtract 12 from both sides. So then we get x is less than 8, and you're done. Okay, so now we have x is less than 8, and we're going to plot it. We need to decide if we're going to have an open or closed circle at 8. Well, since it's only less than, it's not telling us it's less than or equal to, we're going to include an open circle at 8. And then it says x is all the numbers less than 8. So we're going to go, remember, if it's less than, it's on the left side of the number. They're getting smaller on the left side, so we're going to color everything on the left. Okay? All right, let's do another example. D minus 5 is greater than -7. Okay, let's find our variable. So D is our variable. And we need to look at what is being done to D. Well, we're subtracting 5. So in order to undo the 5, we need to use the inverse operations, which means to add 5 to both sides of the inequality. Now, this goes away, and we have D is greater than -7 plus 5, which becomes -2. Okay? Now let's put it on our graph. At -2, we're going to use an open circle because it's a greater than, not a greater than or less than. And then it's telling us that D is everything bigger than -2. It's greater than, so it's all the numbers on the right side. So our inequality sign is facing the D, meaning the D are the bigger numbers. So we're going to color everything to the right. Okay. Hang in there, you guys are doing great. All right, so now we've got a greater than or equal than inequality. So 0.9 is greater than or equal to 9 minus 0.3. We need to isolate, or sorry, not 9, n. We need to isolate the n. So looking at what's being done to n, it's a minus 0.3. So the inverse operation is to add 0.3. That's how we're going to get rid of it. So when I add 0.3, this goes away, and I'm going to get 1.2 is greater than or equal to n. So all of my n values have to be less than or equal to 1.2. You could read it in either direction. So we're going to estimate at the number line where 1.2 is. It's going to be somewhere less than halfway between 1 and 2. And we are going to use a closed circle because it's got the greater than or equals than sign. And now looking over here, it's telling us that n are all the numbers below 1.2, okay? Because if we read it from left to right, it says 1.2 is greater than or equal to n. So that means 1.2 is the maximum number we can have. So we're going to have all the values to the left. All right. So since there can be infinite number of solutions to an inequality, you can't really check to see if you've got the right answer, but you can check the endpoint and the direction of the inequality symbol. So for example, the solution of x plus 9 is less than 15. After you solve this, so by isolating, if I move negative 9 to this side, that's how they end up getting the x is less than 6. And the only real way to check this is to plug in the endpoint. So for example, they're saying to substitute 6 in for x, since that's the endpoint. And if we plug that in, we're going to get 6 plus 9 is 15. And if 15 is equal to the other side, then that is okay. All right, the other way to check for the inequality symbol, okay, so this was to check for the endpoint. So that's why we use an equal sign there. We changed it. Now we're going to check for the inequality. You can substitute any number in for x that is less than 6. So they just picked 4, and they just plugged it in. And after they solved 4 plus 9, they got 13. And so they're showing you that 13 is indeed less than 15. So that is okay. And that's really the only way to check your solution. All right, we've got 2 story problems or word problems to try, and then we're done. Sammy has a gift card. Okay, she has already used $14 of the total value, which was $30. Write and solve and graph an inequality to show how much more she can spend. Okay, so we don't actually know the amount remaining on the gift card. So that is going to be our X, okay? Then it's telling us X, whatever's left on the gift card, plus how much she's used. Well, let's look back up here. She's used $14, so we're going to add 14. Is at most, okay? That means that this entire left side can't be any more than 30. So it has to be less than or equal to 30. Okay, so our inequality is x plus 14 is less than or equal to 30. Well, let's solve the inequality. So the inverse operation of adding 14 is to subtract 14. So then x is less than or equal to 16. So what does that mean? That means that she can spend up to $16. That's how much she has left on the card. So she can spend anywhere from $0 to $16 and still be okay. That's how much she has left on the card. So let's graph this. I'm going to pick 16 somewhere in the middle, put some numbers up here, put some down here. Okay, at 16, it needs to be a closed circle since it's a less than or equal to. And then it says x is everything less than or equal to 16. So it's all the values over here on the left. Okay, so we're done. All right, last problem. Mrs. Lawrence wants to buy an antique bracelet at an auction. She is willing to bid no more than $550. So far, the highest bid is $475. Write and solve an inequality to determine the amount that she can bid on the bracelet. It tells us to let X represent the amount that she can add to the bid. Okay, so basically she can bid up to $550 and she's already spent or bid $475 of that. So we know that she's done $475. We want to know what can she add on to that, okay? So plus X. We don't know how much. What can she add on to that and still be at $550 or under it? So that means this left side has to be less than or equal to 550. Okay, so again, the 475 is what she has bid. We want to know how much more can she bid and still be at 550 or less. All right, so there's our inequality. Let's solve it by subtracting 475 from both sides because we know there's a positive up here. If we subtract, we're going to get X is less than or equal to $75. Okay, so that means that she can spend or bid up to $75 more. So anything up to $75. She can bid 50, 60, anything up to 75. And then finally, it wants us to check our answers. So here's what we can do. To check the endpoint, you take the endpoint, what you solve for, and you plug it back into the original inequality. So 475 plus 75, and we use an equal sign now, 550. Well, if we add 475 plus 75, that will come out to 550, which is indeed equal to the other side. So we know our endpoint's good. Now to check the second way is we just pick any value of X that we're allowed to and plug it in. So X is anything less than 75. So I'm just going to pick 50. That's less than 75. I'm going to plug it into the original inequality. So now we're going to use the original inequality. And I'm going to check 475 plus 50. That comes out to 525. Is that actually less than 550? Yes. So we are good here. All right, so again, make sure you guys understand that all we are doing is we are undoing things around our variable to solve for that variable for the inequality. And remember to use your inverse operations. And that is it.